Welcome to day 3 of Measuring Time is Not Exactly What I Thought It Was. A few days ago, we figured out that there's more than one type of day. Yesterday, we figured out that there's more than one type of year. Today, of course, we're going to figure out that there's more than one type of month. There's 2 types. You're going to make another T-chart in your science journal. You're going to need a definition, you're going to need a length, and you're going to need a sketch. The 2 types of month are a lunar month and a sidereal month. The sidereal month, again, has to do with a full 360-degree rotation. The lunar month has to do with the sun. So it has a nickname, also the synodic month. And synodic means that it has to do with the sun. We are, again, going to make a T-chart. So put synodic or lunar month on one side, and I want you to put sidereal month on the other. You're going to need the definition, you're going to need how long they last, and you're going to need a sketch. We're going to get ahead of ourselves because we're going to talk about this in just a few days, but the phases of the moon, they don't have anything to do with the Earth going in front of the moon. That's called an eclipse. What they had to do with is the sun shining on the moon. I'm going to try to do this with only 2 hands. We are just going to pretend, and I need you to just visualize, the sun is going to be over here. Okay? So the sun is just floating here in space, but I'm going to have to set it down so that I can show you what's happening. The sun is right here. And we live on planet Earth. So if we are looking at the moon, and the moon is in between us and the sun, where it's not causing an eclipse, that means the half of the moon that's lit up, which is over here, is facing away, and we will not see any of this side of the moon because there's no light shining on it. That means that we have what's called a new moon. Let's say that the moon was over here in its orbit, not causing an eclipse, and the half of the moon that's being lit up, we can see all of it. So from Earth, we would see what's called a full moon. If the moon is here, there we go. If the moon is here, this half is lit up, so we see half of the moon lit up and half of it as dark. That's what causes the phases of the moon. We're going to get into that a little bit more in the coming days. But you're going to need to know what causes the phases of the moon in order to figure out the different types of months.
The next unit of time up from the day is the month. Just as per the days of our lives, there is more than one way to measure out the months of our lives. As per the sidereal day, we can use the stars to measure the orbit of the moon about the Earth. The sidereal month is the time it takes for the moon to complete a full orbit around the Earth with respect to returning to the same place among the stars, 27.32 days. But if we use the moon's conjunction with the sun as seen from Earth to measure the length of a month, then we get a synodic month, the amount of time it takes for the lunar phases to cycle through one time and for the moon to return to the same position in the sky relative to the sun, 29.53 days. The synodic month is sometimes called a lunation or lunar month. A separate lesson on the sidereal and synodic month explains the details of why the synodic month is longer than the sidereal month.
So let's take a look at the different types of months. Let's just start with the easy one, a sidereal month. We know that the moon is orbiting around the Earth, and if we just measure where the moon starts, one full 360-degree orbit takes 27.3 days. We call that a sidereal month. The other type is what's known as a lunar month, and that has to do with the phases of the moon. Let's pretend that we have the sun still just floating in space right here, and in this configuration, we would see this half lit up. We would see from planet Earth a full moon. We see the entire lit up side of the moon. And you would think after a full, there's a new moon, a half moon, after a full circuit of all the phases of the moon, after 360 degrees, we would get back here and see another full moon, but we don't. The reason is that as the moon is orbiting, the Earth is also orbiting. The Earth is moving. So it's kind of difficult to do, but as the moon orbits, the Earth is going to change. In this position, we have the sun, the Earth, and the moon all in a straight line. And as the moon goes around and Earth changes, well, after 360 degrees, they're not in a straight line anymore. The moon has to continue to move a little bit, and now it's going to be in a straight line with the sun. So it has to go a full 360 degrees, which is 27.3 days. After it moves a little bit more so that you get back to a full moon, that's 29 and a half days. That is what's known as a lunar month. The definition of a lunar month, from full moon to full moon. The time that takes is 29 and a half days. You can draw a little sketch. And then a sidereal month is just a full 360 degree circle or orbit. That takes 27.3 days. Another weird characteristic of the moon, because it's been orbiting for so long and has such little mass compared to Earth, is actually what we call tidally locked, which means the same face of the moon is always facing Earth. The moon does spin, but it spins at the exact same speed that it orbits. Let's say that we can see the man in the moon. We can see his face. What's going to happen is as the moon is orbiting, it doesn't stay facing the same direction. The face of the moon is going to always be facing planet Earth. And the only way for that to happen is that as the moon is going around, it's also doing this. So the moon is spinning. Here is one 360 degree orbit, but it also, in that exact same amount of time, is going to spin one time. So a sidereal month is one 360 degree orbit, but a 27.3 days, that's also exactly how long it takes for the moon to spin one time. I want you guys to make a Venn diagram in your science journal and fill that in. I'd also like you to answer the question, why is there a difference between a synodic month or a lunar month and a sidereal month? So if I was going to answer these and I was going to fill this out, what do they have in common? Well, they both happen because the moon's orbiting Earth. They have similar lengths of time, but they're a little bit different. I couldn't come up with another one, so they both have the word month in it. What's different? One's 360 degrees. That's the sidereal month. Takes 27.3 days. Whereas a lunar month is 360 plus a little bit more to get back to a full moon. That's one cycle of the moon phases. Takes 29 and a half days. Why is there a difference? I would say one has to do with the moon orbiting one time. The other, that's the sidereal month. The lunar month has to do with how the sun is shining on the moon from full moon to full moon.